Good afternoon. I'm thrilled to be here. I'm also thrilled to see so many of you here with me. As Randy mentioned, I'm going to talk a little bit about evolving microservices architectures. And I think one way to start is to set the stage by telling a story. So this is March 11th, 2017, earlier this year. The place is Children's Mercy Park in Kansas City. And this is the stadium for Kansas City's Major League Soccer team, the Sporting KC. It's a couple of hours before even the earliest fan will come into the venue. But for the handful of SeatGeek employees that flew in from New York that morning, this is an important day. It's also important for the team. This is the first time, first of all, it's Kansas City's home opener for the 2017 season. But it's also the first time that SeatGeek, traditionally known for secondary ticketing, will be primarily responsible for ticketing a US pro sports event. So SeatGeek's history is, for those of you that don't know, it's a startup here based in New York City. It's about 7 years old. Its history is one of aggregation. It's traditionally been a source that knows how to go to the markets and brokers that have tickets and provide user-friendly ways for fans of concerts and live events in general to obtain the best tickets from wherever they may be. And recently, within the last 2 years, SeatGeek brought commerce onto its own platform, becoming, in reality, a secondary ticketing market along with the likes of StubHub and Vivid Seats. And at the moment is in a push to grow further still into the primary ticketing market, the first sale for pro sports teams. And that was pushed a lot by about 6 months ago, or rather a little bit longer now, a deal with Major League Soccer, which made SeatGeek its primary ticketing partner. And Sporting Kansas City was the first client resulting from that relationship. So back to this empty stadium, at this point we had sold all the tickets, and this was the culmination of something like 6-7 months of hard work to retune an existing product dedicated to the secondary market to work in a completely different market. And if this were a commercial, right now I'd be saying something like, microservices made this possible. And it's true in a way. But let me ask you a quick question. How many of you have or work with a microservices architecture? Okay, at least a third. And how many of you, as a secondary question, would like to have a microservices architecture? Okay, another third. So for the third of you that didn't raise your hands, there's a sort of tongue-in-cheek quote that you probably already have a microservices architecture, whether you want one or not. And as I said, it's sort of facetious, but it's also sort of true in the sense that all of our systems are connected to other systems, whether it's payment or logging. And I think it's important, therefore, that we all have some understanding of how to evolve our microservices architectures in reaction. Microservices are fundamentally about change, right? As an architectural pattern, it's one that embraces change and understands that change is going to happen, and essentially includes it in the model as opposed to being too academic about it. And things that change include maybe technology, right? Technology evolves, you want to stay on top of things. You're using a new thing right now than you were 2 years ago, and you'll be using a new thing 2 years from now. Scale certainly causes change. The technologies that worked in the prototyping phase, perhaps inappropriate for the hockey stick growth phase. And then organizations as well. As organizations grow, Conway's law comes into place. That idea that systems, or organizations that design systems, design them essentially mirroring the communication structures of the organization. So as the organization changes, the communication structures of the architecture change. And so one question might be, how does a microservices architecture help in the face of all this change? And the answer is that, or one answer at least, is that microservices is part of this brand or category of architectures called evolutionary architectures, right? This is, as I was saying, something that has baked the idea of change into it, so it deals with it rather than fighting it. And microservices tend to be organized around capabilities. This is, essentially something helpful in terms of mentally organizing our thoughts about what the architecture should be and where the boundaries should be. But as I'm talking today, and I'll go into detail, as I'm talking about evolving a microservices architecture, assuming you already have one. It's more than just architecture that we have to talk about, and I think that's the point that I'd like to try and get across, is we're talking about architecture, certainly, but there are also DevOps concerns with evolving a microservices architecture. And there are even strong cultural concerns with evolving a microservices architecture. And being successful in that evolution involves addressing, at different points in time, each of those. But let's start with architecture. All right, so quick review for those of you who haven't been in the session in the morning, heard more about this. Microservices are all based on the idea of atomic components, really well-defined interfaces, and communication over dumb pipes, or simple protocols. Right? And this idea of atomic components, one capability per component, it's very, very difficult to get that right the first time. If you are transitioning from a more monolithic architecture to a microservices architecture, chances are you're going to get some portion of it wrong in the beginning. And so it's important to then think, okay, how do we change this? Let me give you an example of an area where SeatGeek encountered this. This is an event ticket, okay? There's 6 or 7 pieces of important information on here: your seat, your section, your row, the event date, time, place. But it is remarkable how many different ways that information can be represented on a ticket. And it's actually, incidentally, one of the interesting things about working in the ticketing space is that things that seem like they might be trivial, in the end are actually difficult technical challenges because of the complete lack of standardization in this industry. But back to this ticket. If we wanted to know what section this ticket represents, okay, this ticket says F4ADA. What section is this? If we look at the venue manifest for the same event, we see it's this one, labeled FC4. All right? And this is just a ticket from one market. If we have tickets as an aggregate from many markets, we end up with a situation where lots of different representations of the same piece of inventory need to be aggregated into one common thing so that they can be anchored correctly on our map and displayed to users in a way that users know exactly which seat they're getting. And we accomplish this through a process called normalization, or section normalization. And so to get just a little bit more technical here, this is a cleaned up view of a portion of SeatGeek's infrastructure architecture that, essentially reading right to left, represents what happens when a client, a user, asks for available seats at a particular event. First step in this organization is it hits something we call a listing feed, who's responsible for communicating with all of the markets that might reasonably have inventory for this particular event. Those markets are actually communicated with via specific API integrations that we have with each of the markets that we work with. And those markets will return us real-time information about what seats are available at that point in time. But they do so using that market's terminology. And so the same section may come back from multiple markets with a completely different name and needs to be normalized. So that's something that currently happens in the listing feed. If we look here, there's also something labeled DQ, which stands for deal quality. And as the name suggests, we make an effort whenever we get inventory information from a market to assess the quality of the deal from a user's perspective. How good is this value? How value add is this seat compared to this seat historically, compared to the other options available? And we calculate a score, essentially. Again, because we're comparing this seat to itself in other markets and itself over time, normalization plays a role. And so here's an example where SeatGeek, moving quickly, probably did something bad, in the sense that while the normalization code itself changed infrequently, it did change. And when it changed, it was essentially copied from the listing feed component into the deal quality component, and we went on with our lives. But then we made the situation worse. As I mentioned at the beginning of the talk, we introduced this idea of consumer inventory, which you can think of as a completely new market. That is, individuals individually uploading their own seats for resale. Okay, so in order to support this type of PDF-based upload, we had to introduce a number of new components. But as you can see, now we have people uploading a PDF much like the one I showed, and they've got their own section row seat information from arbitrary sources. So we need to parse that information, understand which seat that user owns so that we can list it appropriately. Again, normalization. So now we had a situation where that same capability needed to exist in 3 different components. So we had a choice. Number 1 would be to duplicate that functionality once again into this new component that we were building. Number 2 would probably be to promote the capability into its own top-level component. And number 3 was to do some sort of monkey work with the listing feed to adjust its interface or add a couple of new endpoints to expose some portion, just the normalization portion of that service so that we could consume it. And you know, it may be obvious listening to it now that option 2 here is probably the best way to go long term. But when things get messy and deadlines are coming, definitely options 1 and 3 are absolutely on the table. But you know, we ended up doing the right thing here architecturally and taking the normalization capability and making it its own first-class component of the architecture. And I think you know, one of the lessons here is avoid duplicating capabilities, thinking between components, right? Thinking in terms of capabilities and trying to make sure that if something and something else share a capability, then perhaps it's time to treat that capability as its own first-class citizen. And one of the ways we can think about how or when is to consider the relative cost. Maybe it didn't make sense for us to do that months ago, years ago, when we just had deal quality and listing feed. But now that we were obviously growing and a significant amount of traffic was going to come through consumer inventory, we needed to do it. The relative cost of waiting yet longer to make this happen was completely what drove us to do it at this point. All right, so considering the relative cost of either doing the work now or putting it off until later can help make the decision a little bit easier. Another architectural consideration is scale. And when we're talking about scale, there is a misperception among microservices architectures that because I have a microservices architecture, if I add another component, it will just work. And let me give you an example from hard-learned experience where that falls down on its face. Again, revisiting this part of the architecture, you know, we communicate with a number of different markets. Great. And they give us information back about seats. But as I mentioned at the beginning of the talk, we are now moving into the primary market where we ourselves are a primary market for certain events. And we knew it was a big deal. We knew also that we weren't going to be able to build it ourselves in the amount of time that would be appropriate and have the quality. And so we made an effort to go out and buy our problem away. All right? So that's great. We've got $60 million less, and we've got a world-class reserve seating, season ticket capable ticketing system on our hands. So in principle, at least, that's fine. Except this is a enterprise C# monolith that we needed to drop into our essentially scrappy startup microservice architecture. So a little bit to give you a sense of why I say scale is the problem here, because there were many problems, but scale is the one that I'm going to focus on. If you look at secondary listings for any particular event, you see something like this. It's sparse. Any particular market knows maybe 1–2% at most of what's available for a particular event. But when you are the primary ticketing system for that event, and you're about to set that event on sale, you know all the seats, which could be, in some cases, 50, 60, 70,000 listings coming back through your primary ticketing system into your architecture. And in our case, this C# monolith was emitting 30 to 50 megabyte SOAP messages, which, because our interfaces were clear and fine, and that was good, but using dynamically typed Python to consume messages like that was never, ever going to result in a performant API. So SeatGeek took its very first steps with .NET Core. I mentioned that, and .NET Core is a fantastic piece of technology, by the way. We're extremely happy with it. But it was just something that we had no familiarity with whatsoever. The conversation between our CTO and one of the engineers, you know, the first crack at it using the WSDL generated 200,000 lines of auto-generated C#. That was something just outrageous for us, something we'd never really encountered. But the point isn't really that. It's that we looked at it as the solution to a problem, which was we were never going to be able to parse, using a dynamically typed language, the type of information that was coming out of this system. So we had 3 goals. One, we wanted to encapsulate the SOAP. So the rest of our architecture didn't know anything about SOAP, and we wanted to sort of limit that. 2, we wanted to interpret the messages, meaning the primary ticketing system is oriented in terms of seats because that's what it knows, but the rest of the markets think in terms of listings, groups of adjacent seats that are spread out throughout the system. And so we wanted, again, to try and see if we could coerce the messages from the ticketing system to look a little bit more like what the rest of the architecture was expecting. And then the third thing is to present a standard interface. All right, so we're going to present a standard RESTful interface that looks a little bit like what SeatGeek's architecture might be used to consuming. So these were all the goals, and these were supposedly the capabilities that we wanted out of this new component that we invented, right, to sit in front of the ticketing system. And that's what we built. We built this thing called the SeatGeek Open API, which basically lived in front of the much more powerful but very awkward API that this new component that we had just bought presented us. And what it allowed us to do essentially was achieve the goal of treating ourselves as just another market. But it had the additional benefit of, by making it public, we were then able to treat SeatGeek as just another one of many potential distribution partners, achieving one of the primary goals of calling it SeatGeek Open, the idea that anybody with an innovative idea for incorporating tickets to live events into their offering might be able to have essentially equal access to the ticketing platform. So, you know, capacity planning, call it what you will, but it's important. You cannot just imagine that your microservices architecture, by dint of being a microservices architecture, will simply absorb any component that you have to put at it. It is important to think a little bit, not just about the interfaces, but what you're going to push through those interfaces. So switching gears a little bit, I mentioned at the beginning that this is more than just architecture. And I think the talks in this session have touched on this a little bit, but microservices as an architecture and platform as a service as an infrastructure paradigm, they essentially go hand in hand. Let's face it, if you've got a microservices architecture, all your components spread out, but you're deploying them to a single Linode instance, you're missing out on a great deal of what that microservices architecture has to offer. SeatGeek happens to operate an internal platform as a service. Technologically, it's based on Amazon Web Services. We use a set of open source technologies like Consul for service discovery and Nomad for scheduling and executing batch tasks. And then on top of that, we layer an assortment of open source tools and homegrown utilities to help us implement our continuous integration pipeline, our deployments. So with Jenkins and Travis, we are a little bit unusual, I suppose, in that we build everything to Debian packages. It's essentially a holdover from the way we used to do it. And we haven't yet changed it completely, but are in the process of moving to Docker. And essentially what this gives us is a couple of nice things, especially in the context of evolving an architecture. Number one, we have independent deployments. Each component is completely self-standing, minimal coordination required. The component can be deployed without any help from any other components, and there's no synchronization necessary. And we treat our infrastructure as essentially expendable, no machine local state. And we deploy a lot. The screenshot here is from a 2-hour period on a random day from 10 in the morning till noon, and it's something like 25 different deployments. So deploying is a consistent part of operations at SeatGeek. All of it is orchestrated, though, and how does it hang together? Through essentially an application manifest, which is basically a description of how this application should be built, how it should be deployed, what environment variables it depends on, and all that information is wrapped up in a JSON file that lives with the application itself, is owned by the team that builds the application, and needs to be maintained and kept up to date. The ops folks basically just run the scripts. And it's important because it gives the team ownership over how their applications are actually configured and deployed into the production environment. And the other nice thing about having a consistent format for this is that as you introduce new technologies and new runtimes that you've not seen before, it's actually possible. This is an example of one of our Python components. It's using pip to install a set of requirements. And the difference between that and a .NET C# application running on .NET Core is essentially a difference in the build command line. So as I was talking about how difficult or painful it was to integrate the actual component into the architecture, from a deployment perspective, having a platform as a service architecture from an infrastructure perspective, incredibly valuable, incredibly helpful in helping us literally to absorb this component into our system without a whole lot of re-engineering, and certainly without impacting any of the other components, again, from an infrastructure perspective. And I think the second piece of infrastructure that needs to really be considered and can be particularly helpful when you're changing your microservice architecture is the monitoring. Been some talks about that already this morning. I'll just reiterate how important it is to have a unified view of a microservices architecture. There's a stack out there colloquially called the TIC stack, which is basically an acronym for the first letter of each of its components. This is not a SeatGeek diagram. This is open source software. And basically what it provides is collection, storage in a time series database, stream processing for alerting, and visualization. And together those four things, because they're uniform across the entire architecture, provide a really nice base for gathering the information you need, storing it in a way that can be asked questions of now and in the future, and then also visualizing it to do real-time alerting or react to it. And so SeatGeek uses a slightly modified version of this where we pull all of our metrics from Amazon Web Services and from our legacy metrics collection using Telegraph. We write it into InfluxDB, which is essentially a time series database. And then Capacitor, as I said, provides stream processing to identify anomalous events that can be worth alerting on. And Chronograph and Grafana put together options for visualizing these things. So to give you an example of what I mean by visualizing, the neat thing about the system is that you can query it. It's all metrics based, but you can query it using MySQL or SQL-like queries and put the resulting visualizations next to each other in ways that help you tell stories with your data, or at least be a little bit more clear about what is happening in your system in real time and historically. And we've found it to be incredibly powerful in terms of being able to go back and look at what happened at a particular point in time, identify correlations between different services, try to figure out if one thing caused another thing or if it was the reverse. Having that information has been a lifesaver in more than one occasion. Just as an example of what kind of stories the metrics data can tell, this is an example of an on sale, which is for a concert. It was done via a radio code that got broadcast over the radio at 11 o'clock. And you start to see people at about 10:58 to 11 o'clock that knew the code already, trying it out. It's not really working. At some point around 11 to 11:02, the code gets broadcast over the radio, and lots of people who are interested in the concert come in to go take a purchase, and it tails off. So all of this, not having any other source of information, being locked in a bunker somewhere, you get a sense of what's happening across your system, which pieces are working correctly, and which pieces are starting to suffer under the load. Speaking of suffering under load, this is the second story that we discovered. Again, shows the value of having this. This is relatively recent for SeatGeek, I'd say within the last 5 months. And it's something that we've come to rely on a daily basis. This is a story about an 8-hour period leading up to one of the Sporting Kansas City events. And it represents the number of times that a user requested to download a PDF of their tickets, which is something that we pride ourselves in not happening too often because we focus on mobile tickets. And it was particularly strange that in the hours and minutes leading up to a game, we noticed almost a 10x increase in the number of PDFs that users were requesting. Theoretically, if they're standing at the gate, they can just show their phone and they don't need to download the PDF. So what was happening? So this graph actually allowed us to begin asking that question, and the answer was a little embarrassing. It was basically our mobile apps, specifically our iOS app, was showing a PDF thumbnail of the PDF, and in the process requesting the whole PDF from the service. So during a time where we wanted the systems to be nominal and not experience a lot of high traffic, we were sort of DDoSing ourselves. And we fixed it. And so the good part of the story is that having this metrics and being able to identify an anomaly like this led to conversations that led to us finding out what was going on. So I think the lesson out of this is essentially having monitoring all over is really something that can be valuable in a microservices context where all of your components are separate and points of failure can really be anywhere. So I think the last thing to talk about of the three is really from a cultural standpoint, okay? And specifically, I'm talking here about alignment. When SeatGeek set out, this is, again, that whole idea of Conway's law, right? Or organizations that design systems are constrained to produce designs that are copies of the communication structures of these organizations. And it's true. And we got a first-hand education in Conway's law in the process of integrating all of these new components to try and build SeatGeek Open. Starting out, things were positive and things were going well, but SeatGeek, we started missing a couple of our internal deadlines. And we care about these sort of things. And it was sort of the result was a set of meetings, a set of investigative, poking around to try and see why were we not delivering as well as we thought we ought to be. And part of the reason was that despite having a team structure that was oriented largely around capabilities, we didn't have a team structure oriented around the capabilities we wanted given this new business. All right, so this is an extremely simple view of SeatGeek's engineering. And apologies if anybody's watching and belongs to a team that I've left out. The point is that this is how the world looked as a secondary market before we tried to move into primary. And once we acquired this new ticketing system, we built a team around trying to integrate that system into our existing system. So this team was responsible for figuring out how to get this ticketing system and make it work. The challenge with that was that making it work from a product perspective involved aspects that were the responsibility of each of these other teams. SeatGeek Open, SeatGeek's checkout needed to know how to do fulfillment for primary tickets. The platform needed to adjust the way that transfers and resales were handled so that we could accommodate communicating to our own ticketing system instead of to a third-party market. The mobile device needed to show the barcodes correctly, and the web team had the biggest changes of all because SeatGeek as a company was now dealing with things that we never thought we'd ever have to deal with. Who are season ticket members, and why do they need to manage their accounts? There was a huge change to our web-facing product. But the problem here is that nobody owned all those changes. Organizationally, we had all these new capabilities that we were building, but no one team was essentially responsible for owning them. And so in addition to making architectural changes and in addition to working on all of our development and operations, we needed to rethink our lines of responsibility organizationally in the engineering department to accommodate this change. So we created a new team that we called the Greater SeatGeek Open Team, much to the dismay of the SeatGeek Open Team, and re-centralized all of those responsibilities that still existed but had no primary ownership into the primary domain of this team. And we took members from each of the teams to form this. So the domain expertise was there and the responsibility was there. And we began to start to hit our milestones because the right people were thinking about it and the right people were responsible for the changes that need to be made. So I think one high-level point that you might take away from this is that if you're going to evolve your architecture, if you're going down this path, it's not purely an academic exercise that happens in a vacuum. There are real people and there's real consequences to missing things. And so sometimes maybe it involves taking another look at the organizational responsibilities, specifically around the development and delivery of the components that you've got. I think any discussion of evolution and change in software is probably incomplete without mentioning documentation. It's something that we all understand that we need, but it becomes incredibly important in a microservices system. And to the extent that like the microservices mantra is, you should be able to integrate with my service without having to talk to me because I've got these really well-defined boundaries and everything is easy to inspect. That only works if the knowledge that lives with the team is published somewhere. Knowledge lives with the team, and that's fine. But the reality is that teams obviously change over time, and that knowledge gets diluted as people leave the company, or maybe a component just works and nobody's touched it for years. If that is the case and there isn't some documentation for it, then when it comes time to start engineering change, you're going to have to rediscover a lot about your architecture. This is something that SeatGeek absolutely fell into. We are much better now than we were at the beginning of this year. We've gone through an entire corporate push to rediscover some things, honestly, about our components. SeatGeek runs approximately 40 to 50 services in its microservices architecture that together comprise our product. And I would say that in some cases, there was 1 or 2 people that knew some of those services very well. And in some cases, there were 0 people that knew a service very well. And I think that's a situation which is okay for a while. It's never great, but it's okay for a while until you start trying to change things. And you need to figure out, well, what's the impact going to be? What's going to happen when I shove 10 times as much data down this pipe? Which component is going to start complaining? So it's important to think, I think, one tongue-in-cheek way to say it is that your documentation needs to be highly available in a microservices environment, right? I need to know where to go to get it. I need to know that it's going to be comprehensive. I need to know that consistency among the documentation is important. It's really an enabling tool for a team as a whole that's in the midst of growth, like SeatGeek is and like many of your companies are, I'm sure. It's really an enabling tool to have a centralized repository of information that a new hire can come in and say, you know what? I don't know anything about this thing. I know my little corner. What does it connect to? And how does that work? And to branch out from there. So let me go back to March 11th, 2017. Empty stadium. As the time started to draw near to where we would finally let fans in to the event, a number of us were packed up in one of the press booths where they usually do the radio broadcast. And everybody was tense. Everybody was looking at their screens. There wasn't an outlet to be found. And this was really, as I said, the culmination of about 6 months of hard effort, organizationally, infrastructure, architecture, teams coming together, trying to make decisions about how do we change this company's engineering culture, engineering architecture to support this brand new business opportunity. And so what I would say is that as the stadium actually did, we had sold all the tickets. We had connected everybody. We had figured out all of the engineering challenges with getting these people's tickets and barcodes to show up on their phone. The one thing left was, could we get them through the gate? Would they come through the access control? Or would we have a riot on our hands? And so the feeling of going from that empty stadium to one in which 17,000 fans excited to see their team take the field and play their first game of the 2017 season was fantastic. As I'm sure you can imagine, when the national anthem played and the rockets went off, I think it was a big feeling of relief, but also of accomplishment. And I think, at least for me personally, I went around the whole night feeling about like that, because it was the feeling of a lot of hard work coming done, and also, to no little effect, the feeling of knowing I had a job on Monday because it had all worked. So it was very important. And I think, I said at the beginning that microservices made this possible. And I think maybe a more appropriate construct of that would be, microservices are the reason we could even begin to think about doing something as ambitious as approaching the primary ticketing market by buying a company and integrating it and doing it all within 6 months and ticketing a pro sports team from a company that had never done anything like that. Microservices absolutely made that possible. But it was the evolution of the microservices architecture that took us to the edge more than once. But I'm convinced, though, that as a product, we're stronger, we're operationally stronger, and certainly as a company, we are much stronger for having gone through that effort. So my hope is that as each of you take on your ambitious projects and audacious goals, that some of the lessons that we've learned at SeatGeek with respect to evolving architecture and working your architecture and your DevOps platform hand in hand, and being willing to examine aspects of your culture that may need to change in sync with your architectural change. Hope that some of those lessons will help you evolve your architectures faster and with fewer headaches. Thanks.